Hello and welcome. Let us read this problem. A stone is thrown from point A with a velocity of 4.5 I cap plus 7.6 j cap meters per second. It is found after time t at point B with a velocity of 4.5 I cap minus 3.4 j cap. Again, this is also in meters per second. Find time t. Okay, now see, this is what you are told is, let's quickly make a sketch. This is a initial velocity of a stone and it is 4.5 in I direction. So let's say this is 4.5 in I direction and 7.6 in j direction. So 7.6 in j direction. So this is 7.6 j, this is 4.5 I, right? Okay, and this is your velocity, right? Now this stone is going to it would travel in certain path and then it will come down. Let's pay attention to this. The I component, that means x direction, is velocity in x direction is 4.5 meters per second. Okay, and when it reaches the destination after time t, its horizontal component remains as 4.5, and this is natural because this is a projectile. The velocity in x direction or x direction doesn't change. Okay, whereas velocity here, initial vertical velocity is 7.6, and this initial vertical velocity now this velocity now becomes minus 3.4 meters per second. That means it is downward. Here it is upward, which means this projectile has reached the maximum height where its vertical velocity has become 0, and then it has started going down in negative direction. So somewhere here, let's say here somewhere, now we have the point where horizontal component of the velocity remains 4.5 I and the vertical component, let's say it is 3.4, right? And this is, let's say, 3.4, and this is the velocity. Okay, so these are the 2 points. Now see, we can immediately say, we know that this is change in velocity. If you want to find out, we can consider only vertical velocity. It's like, as we have explained, this can be treated as a problem where the stone is thrown because we can separate horizontal and vertical motion in a projectile. So we can imagine that this situation is similar to a stone being thrown vertically up with initial velocity of 7.6 meters per second. This stone will move up, reach somewhere, and will travel backward. Okay, and when it is traveling down, its velocity is now 3.4 j in this direction. So it's minus in this direction. So that means this velocity now is minus 3.4 meters per second. What we are asked is how much time. So time is essentially final velocity minus initial velocity upon acceleration. V is u plus at. So if you want to find out time, which is essentially t is equal to final velocity minus initial velocity upon acceleration. What is final velocity? Final velocity here is minus 3.4. What is initial velocity is 7.6. So this is minus 3.4 minus this minus initial velocity is 7.6 upon acceleration. Acceleration is, the stone is in the air, that means acceleration is minus g, and g we are considering as 10 meters per second square. So it's downward always. So it is minus 10. And this is 11 upon 10, minus 11 upon minus 10. So minus sign goes and it is 1.1 second. That is the answer. So it's 11 upon 10. So it is 1.1 second. That is the answer. Please, what you need to remember here, I've drawn these two figures, but actually this is what we have to consider. We have to consider, we need to say that the vertical motion can be isolated. This situation is as if a stone is thrown vertically up with the same vertical velocity. That's it. The horizontal velocity doesn't come into picture. right? And that's the important point. Okay, thank you.